Hello, this is a short video presentation on simplifying radicals. This is the beginning of Unit 5, which is basically square root functions. A lot of what we do in this unit is extremely similar to the last unit because we will be dealing with quadratic functions. However, our solutions will not be rational, or oftentimes will not be. They will be irrational. All right, so let's simplify a square root. What we've been doing all along is looking at things like the square root of 16. Notice I'm using the radical symbol. That means it's the positive square root. We know the square root of 16 is 4 and negative 4, but the radical means it's just positive. Equals 4. Well, what happens when the square root is not a perfect square? Square root of 32, for instance. How do we simplify that? And that's what we're going to be doing today. Today we're just going to look at simplifying square roots. So to begin with, we have a property of square roots. And basically it says the square root of a product is equal to the square root of the first factor times the square root of the second factor. So the square root of a times b is equal to the square root of a times the square root of b. So the square root of 16 times 2 would be equal to square root of 16 times the square root of 2, or 4 square root of 2. So the square root of 32 is nothing more than 4 times the square root of 2. Notice that this square root here is a perfect square. All we're going to be doing is taking the number inside our radical and looking for the largest perfect square. So, for instance, the square root of 27. What is the largest perfect square that is a factor of 27? Now, if you know this off the top of your head, you can just write it. 9 times 3. If you don't know it, then we'll have a procedure for going through that, which I'll go through in a minute. So this is equal to square root of 9 times the square root of 3. We don't need the dot. You can put it there if you want, but we don't need it. Which is then equal to 3 times the square root of 3. All right. Let's look at some cases where we don't know the largest perfect square. For instance, the square root of 180. What is the largest perfect square? Well, I don't know. So we can break up 180, and we've done this before. And we start with prime factors. 2 goes into 180 90 times. 2 goes in there 45. 2 doesn't go into 45, but 3 does. 15. 3 goes into there 5. So 180 is equal to 2 times 2 times 3 times 3 times 5. So 2 times 2 is 4. So the square root of 180 is equal to the square root of 4 times 3 times 3 is 9, square root of 9 times the square root of 5. Square root of 4 is 2, square root of 9 is 3, and we end up with 6 square root of 5. Now, The other thing that you can do, I'll do this in a different color, you have these two 2's, they come there as a 2. You have these two 3's, and they show up here. You have one lonely 5. What? One lonely 5 there. It shows up inside the radical. All right, let's look at another one. Square root of 500. Now here, we did what's called a prime factorization. We broke 180 up into prime factors. But if you look at the number and you recognize the largest perfect square, because it ends in 2 zeros, we know that the largest perfect square is 100. Or we know a perfect square is 100. So 500 can be written as 5 times 100, or we have the square root of 100 times the square root of 5, or 10 square root of 5. This number always goes in front of the radical. All right, let's look at one more, the square root of 432. Ooh, that's kind of beastly. 432. 2 goes in there 216 times. 2 goes in there 108 times. 2 goes in there 54 times. Be careful with your division. 2 goes in there 27. 3 goes into there 9, and 9 is a perfect square. So I'm going to stop. So we have square root of 4, because 2 times 2 is 4. We have another square root of 4, because 2 times 2 is 4. And we have the square root of 9, because that's a perfect square. And what's left, I need a color that I haven't used. We'll go with the blue again. What's left is that lonely 3, this guy right here. So we have 2 square root of 4. Square root of 4 is 2. Square root of 9 is 3. Radical 3. Or 12 radical 3, or 12 times the square root of 3. Now, this step right here that I'm highlighting in yellow, we could have completely bypassed. And we could go straight to, on color, 2 2's, we have a 2. 2 2's, we have another 2. And square root of 9, oh, I lost my, can't find it. Square root of 9, we have this 3 right here. So we can go straight to that. We don't have to write this. If you want to, if it's helpful, by all means do so. All right, today what we're going to be doing in our homework is looking at simplifying square roots, simplifying radicals. This video was found in the Unit 4 notes and the Unit 5. All videos in the future will be found in Unit 5. Thanks for listening and have a great day.